we will build together a real application, Fashion Buddy, and it's technical content. So today with me, Melissa. Melissa, maybe you want to introduce yourself?
Yes. Welcome everyone to our workshop. My name is Melissa. I am a solutions engineer here at DataStax. A little bit about me and stuff that I do. I come from a computer science background, but started going into the solutions engineering side. So I talk to a lot of users like you, developers like you, who are in the Gen AI space, and I'm able to show them a lot of our sample apps with our products, especially Astra DB. And yeah, Fashion Buddy was something my team and I made. So I'm really excited to showcase that with you all. And we're using a lot of architecture that DataStax provides, such as RagStack, LLMs that you might see there on the slide as well as mentioning other Gen AI tools like LangChain, and we might even throw in a little bit of LangFlow in there too. So here's my contacts, and that's me. Cedric, back to you.
Yeah, right. So thank you. Oh, by the way, you have our coordinates on the top left-hand corner. So, feel free to reach out to us. This is why we put those content. The session is recorded. So, since sometimes we are moving too fast in the end zone, do not worry. We will give you everything, all the code, all the source, all the way to test the thing. So I'm Cedric Linven. I'm software engineer at DataStax. I've done a couple of workshops already last year, but 2024, I guess it's one of the first. So I'm super happy to be back in front of you, doing some real technical session. So I'm an open source developer doing a lot of Java, but today it's Python. So let's go with Python. Python is cool as well. I've done some Cassandra, and I'm also working on multiple AI projects, obviously. So what do we do today? So today is practical. Okay, so it's a live. You can ask your question live. So we are live on Chromecast, on YouTube, on LinkedIn, but we cannot have eyes everywhere. So we will monitor mostly the chat and also the Q&A in Chromecast, where you see those icons to chat with us, ask questions, and if we do any poll during the session, we will provide you the GitHub link. It's already on screen, by the way. The GitHub link, the code, the slides, everything is giveaway today. If you stay with us up to the end, we are playing a quiz, really 5 minutes, where you play with your phone, answering 4 questions. If you answer fast, you win, my T-shirts. Not exactly mine. I'm not Ronaldo or anything like that, but at least the same as me, and it's pretty cool. So
they want the one on your back, Cedric.
Stay up to the end. Okay, it's pretty practical. So this is what we will build. We will interact with one AI provider, which is Google, and their solution, Vertex AI. We will interact with a model called Gemini, and we will use the API from Google. Okay. Our application, we will go with multiple steps. So first, we will just show you the Vertex AI tool with the user interface, how to use it. But then we will install a Python, and we first show you how to use Vertex AI with Google Colab. Then we import a dataset. We use a database to interact and add some context on what an LLM cannot do. And after that, we move fully into Python, build a Python application called Streamlit, and deploy in the website. Speaking of deployment, maybe Melissa, right away, you can already show what the application look like, right?
Yeah, of course. Let me share my screen. Yeah.
Let me stop sharing. Okay, you will have those little transition where we switch like that. So let's see. Yeah, I see in the chat. Hi, everyone. Or the URL of YouTube. Yeah, the YouTube channel is DataStax Devs. So we probably have a single live right now. Yeah, thank you, Andy. We're so super excited to be here. Okay, so now you know it's live.
Yes, we are live. We are monitoring live. And if any questions, please feel to drop those in the chat as Cedric was mentioning. But this is our app that we are building today. So Fashion Buddy, Cedric was mentioning, it's all in Python, and this is being deployed on Streamlit. So what does it do, right? What are we trying to do? If I'm a shopper, I will download an image and I will upload this image. I'm trying to find some similar items to the image that I am uploading here. So by doing that, I can select some filter on the left side and then now recommend me some products that are similar to the items that I'm uploading. And once I click the recommend products, I should expect, cool, some options that are similar to even the whole outfit itself. So this is some shoes, a bag, even the striped sweater. So cool. How do we do this? How are we able to analyze or interpret the photo, and then how do we recommend these products as well that are similar to the photo? We will go into that today and dive deeper as we go in through the code, but just for your reference, this is what we are building today.
All right, nice. Okay, so now I'm sharing it in. Let's go. Here we go. We are getting good at that. Can you see my screen, Melissa?
Yep, you're good.
All right. Okay. So we will alternate a little bit of theory and go to hands-on. Okay. I try not to go over 10 minutes of theory. Okay. Still, the session is for beginners. So even if you have little experience with Python, we can just read through the code. It's okay, right? We will not ask you to actually code. You will use existing code. So reminder of generative AI. You may have heard about it with, obviously with ChatGPT or the Gemini and all other LLM providers, but it's not new, right? So if you want to position generative AI in the middle of data science or artificial intelligence, this is how we position that. Actually, it's a slide from Google. I stole that slide from a Google guy. So artificial intelligence is the wider spectrum where you get the machine learning with supervised algorithm, unsupervised algorithm. The deep learning, which you have this neural network, recursive, and the generative AI, it's again just a little piece of this, leveraging those neural network to produce some content. So different type of context, text or image. Here it's put Imagen because the model it's called Imagen 2 for Google. But for OpenAI, you may have heard DALI, or if you're using any open source model, you should check Stable Diffusion, which is a start to generate image. So this is the landscape of the LLM and the model in March 2024. As you can see, the number of parameters is keeps growing. So the amount of data to train is also growing, but here you see the amount of parameters. So why those parameters are important? So here, the more parameter you add, the more use case you can do. So it starts by transformer, language understanding, summarization, and then translation. Let's say all that was there already 5 years ago. But when you add billions of parameters, now it starts to reasoning, do code completion, do logical inference, and stuff like that. So nice animation, but this is because the number of parameters are keep growing, that also we can do more and more use cases. So Gemini is newish model of Google. I think it's probably 2 years old now, which is their new king model built by Google DeepMind. And the thing is, which is nice with Gemini, it's a multimodal language model. So what does that mean? That means that you can talk to Gemini by asking questions with both an image and the text. So if you just interact with the chat just with text, yeah, you can have a discussion one by, and the LLM is aware of everything happened before. But if you also introduce image in the chat, Gemini is still able to pick what's going on and do response according both the text and the image. So let's say you are a marketer and you want to generate multiple images with the same tone, the same style. It's not easy to do because you ask for an image, you get something, and you change a little bit your question, hoping that you will just have a little tweak. Well, most of the time you get a totally different image. But if you say, oh, use the previous image as a standard, this is what I like, what I don't like with the previous image, generate a new one. Now you have a chat with both image and text. So pretty cool. And this is actually what we will show you. So it was good to show. Google Bard is no more anymore. Now it has been replaced by your Gemini web user interface as well. Everything is called Gemini now at Google, pretty easy. Okay, so with all these parameters, what are the use case? What can you do with that? So the language, okay, not surprising, even with small number of parameters, you could already do a summarization, classification, the old neural network thing. But now you add code generation, completion, speech to text, text to speech. I mean, most of you probably have seen the demo, the multiple demo, both from OpenAI, from Google, from Microsoft during the last 2 weeks, and the latest from OpenAI, especially where they introduced the model GPT-O. And actually now you don't even have to touch your keyboard anymore. It's all text to speech, speech to text, and the model will reply with a lovely voice and do all your stuff for you. And vision. So vision is what actually capturing the image information. So when you're interacting with both chat and image, this is actually the vision that will get you the meaning of your image. Okay, I told you not too much theory, but I need to position the building block today. In Fashion Buddy, we are using language and vision. Okay, and without further ado, the lab one, as I stated, will be using just your browser, interact with Google, and also prepare for what's coming. Create a database using the web interface, because this little guy will take a few minutes to start. So you do that with Melissa, and after that, you come back to me and we keep going with the theory. Yeah, I don't have the good role, Melissa, today. What I'm doing all theory and you have all the fun.
All the hands-on stuff. I know. Well, actually, we have one question in the chat if from Srini. So Gemini is like anthropic plus stable diffusion in some sense.
Yeah, kind of. So Anthropic is actually the company who has a model which is called Claude. So, and Claude has a number of parameters, and as far as I know, Claude is can only interact with text. So yeah, Gemini is has a bit more and can do both text and image. Yes. So
and Srini, we'll see that here in just a few moments with this lab one. So I promised you all this is going to be hands-on, and we're going to get into that. So actually, let me share my screen. Yep, thank you, Cedric. So I'm going to share some links. If you're on the Crowdcast, they are right below us here. If not, they should be also attached, I think, to the description of this workshop. So if you're on the Crowdcast below us, you should see the sign up for Astra. So let's all do that. If you haven't done it already, please take some few moments to do so. Let me share my screen and we can walk through this together. So if you click this below, I know, sorry for the infinity screen share, but there is some link here. There is some link here, sign up for Astra. Click that, it'll bring you directly to our sign up page. So you can see here, you'll sign up with GitHub, with Google, or with your email. So please take a few moments to do so. Me, I already have a Astra account, so I will log in with my Astra account. I will sign up with Google. DataStax. And I'm hoping we have some familiar faces with our Astra platform. I'm going to give a few seconds to folks who have not created their account yet so that we are all on the same page here. Okay. So, are we good to move on, Cedric, you think?
Yeah, let's wait for the chat and see if people
Okay.
are doing that with us, and do not rush. Okay, so yeah, Pranav Telos is connected. Yeah, so now you
Okay.
can keep going.
Okay. Thank you, folks. All right. So, Astra, this is our product, right? We are a database that is implemented now vector search and vector features that are very integral into generative AI application development. So you are here in our dashboard at this time. First things first, let's get you familiar with some key things here. Anina said she tried Astra. Cool. Thank you. What we will need for this workshop later on when we go a bit more hands-on is a database. So how do we do that? We can go ahead and click create a database, and let's all give it the same name. Let's do Fashion Buddy Workshop. For provider, you can select your preferred provider, and then for region, these things don't really matter for the purpose of the demo. So you can select any defaulted region, and then select create database. And that takes a couple minutes to spin up. So we will visit back here in just a moment. So next thing here is to get signed up on Vertex AI. So again, if you are in the Crowdcast, I put the link here down for Vertex AI. So if you have not signed up for Vertex AI, it should look like this on that link. Sorry, not like this. Like this. You sign in with your normal Google account. So if you already have a Google account, great. And then you just select try it in console, and then you should be directed to the Vertex AI platform. So I'm going to slow down again here. I just want to make sure that everybody is now in Vertex AI. If you are, please say yes in the chat. Where did you find Vertex AI? It is, I linked it here. Right under our web video feed, there should be a Vertex AI link. So you can select that.
Yep.
And then it'll bring you to the sign-in page.
Yes, you go to the Google console. You got this big console. You can enter Vertex AI in the search bar. It will show you. And because it's their shiny product, they are linked directly to enable everything you need to use it, and going into their what they call the studio.
Yep.
Oh yeah, thank you, Thomas. He shared the link.
Oh, thank you. Thank you, Michelle, for sharing the handy links too. Okay, amazing. So I'm going to move on from here. So this is Vertex AI again, right? We will be doing, so if you have not yet had a project created, we must first create a project. So I already have one here. If not, you can go into this toolbar up top and then create new project. Give it a name. It will default it to you itself. And then once you're here, I want to grab several credentials that we will be using in our development hands-on workshop a little bit later. So if we are all here at the select the project screen, you'll see the ID. Go ahead and save that ID, copy, paste it, put it in some notes for later. Good. We have a few seconds here, and we'll wait to move on. Did everyone get their ID? If yes, you could put a yes in the chat as well.
Yeah, and we move fast in the beginning, so we can pause to be sure everybody has the time to manipulate. So there are so many services in Google Cloud, and even in the AI parts, you see there are so many pieces. So in the Vertex AI environment, you can find here some ready-to-go notebook to train you. If you look on the menu, there is the model garden. So maybe, Melissa, you can click on the model garden to see what it looks like. It's the second link on the
Yes.
on the top. Yeah, so here you see Gemini is the multi-purpose model. So slower, but more deep because more parameter. ImageGen is like the single purpose image generation. So, doing that. Gemma is an open source model that you can actually download and run locally. Chirp is probably their coding. So a lot of models have not so many parameters, but are used for a single purpose. So completion, code generation, text to speech, text to image, text to video now, but this one is not been released by OpenAI, Rosa model. The trick, and you saw that those guys are releasing the Gemini Flash, super fast, but not so many parameters, and Gemini Pro with 1 million token context window. So no, they are not multimodal. So what we call the token window is how many elements you can put in your question and in your answer. Yes, so Chibuzo, yeah, that's activity that Vertex AI will try you for a free trial and will give you some. I think he gave you like $300 to
Yeah, you should get some
try.
credits.
So yeah, you still need to provide a billing account that he will not use, but that's how they opt in.
Yeah, good call out, Cedric. So it will ask you to provide the billing account. If you go up to the three dots on the top right, there's billing account management. That's where you can add that there. And then for the purpose of the sample app, it won't be a lot of consumption. You won't be utilizing a lot of credits. So as we follow along, just wanted to call that out.
Yeah, everything manner.
How can I go to Model Garden? If you are in your Vertex AI homepage, it should be on the left side under Tools.
It's the second link. Yes. It's also there. You have the if you click Model Garden, you see the Model Garden, and here, see there is all these model that you can pick whatever you want. So Vertex AI is like a huge proxy with an API, and you as a developer, you are using the Vertex AI API, and under you can deploy the default model, but you can also ask Google to actually deploy a model like Llama 3, and you can interact through Vertex. And just to avoid to confuse. Also, if you go back on the menu on the side, there is Vertex AI Studio, and you can actually play a little bit if you want.
Yeah. Let's play around with and really see what Gemini can do. If we're still following along, you can do this too, or you can just observe. So on the left side, we have the Vertex AI Studio. You can actually try Gemini. So we could just talk directly to the LLM.
And here you go. So here you have the prompt, the question you ask, and on the right side you see all the settings, all the little parameter that you can use to tune your request. So the name of the model is the most obvious one, but then you do have a couple of others below. So one is the temperature. So it's between 0 and 1. There is no one better than the other. If you go to 0, it will not be creative at all. It will be almost predictive. You know exactly what it will do. You ask twice the same question, you get the same answer. But the more you get to 1, the more creative it's become. So you can say maybe it's subject to hallucinate. It's possible. But depending on what you want the model to generate something a bit maybe fancy. If you're a marketer or a sales, maybe you want to try multiple things and have the choice.
Yeah.
Yeah, below. Vas-y, go. Yeah, so go for it.
Yeah. So let's see it in action, right? Like if I'm using one of our DataStax marketing images here. So I want to ask maybe what is this photo? Of course, we have a rhino with some wings, but let's see what Gemini tells us when we submit this request. So if you're running into this issue, the billing disabled, this means that you have to add the billing account. So again, it's just
Yeah,
asking
this is
to add that. Yeah, it's asking you must add this, but you won't be charged on that. You have some free credits, but it's just some Google thing to add the billing account. So if you are following along and that's what you are receiving, then that is how to handle this error.
Just somebody ask, can you just show again where you find this Vertex Studio?
Yeah. So if you are in our dashboard, you have some toolbox on the left. Vertex AI Studio should be the third header here. And then if you just go into overview, actually, you can go immediately to
maybe
the
you can
one.
just maybe language will work. Yeah, never mind. Yes, the recording will be available in Aristo. So as soon as the Twitter, the YouTube live is gone, it's there for you to pause and redo. This is also why sometimes we are moving, and I think now everybody had the time to look at the UI, and we should that the Astra database is probably now started, so
Yeah.
we should go back a little bit in theory before moving into code.
Sounds good. And one thing, sorry, before we go back, we all saw the Vertex AI Playground. If you started up your Astra database and you have that running, you can now grab the database details. So I asked you to grab your project ID from the Google project console. And now let's set aside on your database your API endpoint. So go ahead, copy that. And then we need to generate a token as well. So generate token here, and you can copy and paste this, and those 3 credentials we will need for our notebook later. Okay. Good. I will answer any questions in the chat, but I'll hand it back over to Cedric to continue with the theory.
Okay, so now let me share my screen. Back to me. Okay, so the purpose of these 10 to 10 minutes hands-on was really for you to get your Vertex AI project ID and in Astra your database URL and the database credentials. This is mainly what we will need. Okay, so when you interact with your LLM, you are doing a prompt. So what is a good prompt? Just asking the question to the LLM is not enough. I mean, you can iterate, and you iterate a lot before finding something super easy to do. So there is methodology called prompt engineering to help you ask the question to the LLM. And it's not rocket science. It's just adding the proper area in your prompt and use that as a checking list. So you need a context. You need to tell who he is. You are a professional marketer and your mission is to help here and that. It's the objective. You also need to tell who. So that's your mission. That's your directive. This is how you should answer the question, and you should also provide the constraint. This is how you want you to answer as a table, as an image, with which style. It's also very important to tell the LLM what is not accepted, what is forbidden. So if you start implementing an AI app and a chatbot that will answer questions with those technology, he will try to answer everything. Even if you put the temperature to 0 and try not to be creative, it will still try to answer as best as it can, even if it cannot. So there is a good practice, which is always put in the prompt. If you don't know, say you don't know. It seems obvious, but that's what you need to do. And yeah, be careful. Just side story. Some company have been, accountable of what the chatbot is saying. So, be careful. But just you and the LLM, maybe it's not enough. So it's not enough because LLM has a fact date. So it's trained once, and after that it needs to be retrained, or you will have a new version of the model. But let's say Gemini 1.5 has been trained. That's it. Everything that happened from the training date and now, he does not know. He also does not know about your data. If you run a company and you want the chatbot to answer questions regarding your product, your documentation, what you are doing, just going with the LLM is not enough. So you need something else. And this something else is something you add in your prompt, something you add at the end of the prompt, or you add information about you, about your document, about your website. I saw before a question in the chat asking, how do you put a PDF in that? And this is actually what we will explain you today. So the pattern is called retrieval augmented generation. So you will take your data, put in a new type of database, and this new type of database will be used in your query. So in a database, the database type is called the vector database. Okay, so in a vector database, you saved, what surprise, vectors, because in a database, the data is saved in a way to optimize all the queries, all the reads. So here, we want to search and compute some meaning similarity, semantic similarity in between sentences. Why do we want to do that? You ask a question to the model, and we will ask the model, find me all the information that is super close to the question and is part of your documentation. Well, to do that, we are trying to find meaning that is close to the question you ask. So we do a similarity search, and this computation is done with vector. We compare vector to vector. So a vector database, we expect the vector database to save your vector and also to be able to do this semantic comparison. So at DataStax, we have been behind the open source project, Apache Cassandra. This is also what I got in my t-shirt. So it's a NoSQL database, column-oriented, that been there for a while, that can do availability, linear scalability, low latency, and global distribution for very technical, for very easy to explain reason. It's not FUF is high availability because on that database you have multiple nodes and the same data is on multiple nodes, so you can lose a node. It's not a big deal. It's scaled linearly. So what actually we did, we enable vector in Cassandra. And what you just created before on Astra DB is actually a database as a service that give you this Cassandra with the vector enabled, and on top of it, an API to interact with. Because nowadays, we don't really want to interact with drivers, low-level drivers, and we expose an API, really look like Mongo-ish API, where you do find one, find many, find vector. Okay, so how do we do RAG? So you provide a document. The document needs to be splitted into chunk. And the chunk will be transformed in a vector. A vector is called an embedding. And why do we chunk? Well, we chunk because a vector can only encode, not so many meaning. Also, maybe you don't want to have multiple meaning in the same vector. You want, single purpose meaning. So when you do the chunking, that's the framework will already try to chunk not in the middle of nowhere, but chunk at the end of a group of words or at the end of the sentences. Try to isolate what has meaning. And also, it's not a hard cut. It will try to make the chunk override one or each other, because then you can retrieve later consecutive chunk if you need to. So your data is split, transformed to vector. The vector is saved in a vector space. When you save your vector, you can actually add metadata. And that's also what you expect now with those vector database. You want to search with vector, but you maybe also want to add some criteria, like the name of the file, or the people who actually have access to the data, or all the kind. So here in Fashion Buddy, we want the metadata to be the type of clothes. So now you can say, find me all the clothes that are super close, that are super similar to the image or the text I provided you, but that also needs to be this piece of like a jacket or a shirt, and that is a metadata. So when you search both on vector and on metadata. So this is how you insert the data. Now, when you retrieve the data, you ask the question. The question is also transformed as a vector. You perform this similarity to find all the chunks that are close to your question. And this is exactly those chunks that will be happened at the end of your prompt. And voila. So now when you ask a question to the model, you put the constraint, the limits, but at the end, you add something like, and to help you with your answer, consider this piece of documentation. And here you got all the chunks coming from documentation. Okay, so I think I did 10 minutes. It's already back, time to go back to code and stuff. So now we keep Vertex AI, we keep Astra, but we are showing you some Python code in a Google Colab, web-based, nothing to install, just click on the link, and we will go into the different steps you need to do that RAG pipeline. And yes. Now I think it's back to you already, Melissa.
Back to me, yes. So lab 2 here again, I'm going to share this Google Colab with you. We're going to see how to import the data, see how the vector embeddings are being created, and then we're going to actually we're going to call Gemini as our model and a BLLM to generate the response for us, and then perform the vector search, of course, with Astra DB. So if you are following along in the Crowdcast, I will share the Google Colab below. This link is where we'll be doing a majority of our work here. So click along, and I will share my screen. Sorry. Okay.
Oh.
So folks who are following, I shared the wrong screen. This is
and
these things happen.
You show all the dirty details now.
My secrets are out. Just kidding. Okay. All right, folks. This is a hands-on, so we'll be going through these things pretty step by step. So just to review, where are we so far? We want to build Fashion Buddy, the demo that we showed in the beginning. How do we do this? So we have to bring in some data, vectorize those data, turn them into embeddings, save them into Astra DB, which is a vector database. And then from the user side, to retrieve this data, if we are going to submit a query, we have to vectorize that query, do a vector search to Astra, and then generate the response. Now, that all means a lot of craziness, so let's just go ahead and do it. At this moment, we should have our Google project ID and our Astra credentials that we got from our database. So make sure you have those things handy. And if you're following along, we will start off with installing some Python dependencies. So Cedric mentioned that we will be using, of course, we need to import the Google Cloud Platform and then this RagStack AI. RagStack, he just mentioned RAG, RAG, Retrieval Augmented Generation, which is our platform here at DataStax. Think of it as a one-stop shop for all of the tooling, the accessing your models, communicating with your Astra Vector database, all of these operations that you will need in developing your GenAI application. This cell block here will take a few minutes, so perfect for some time for folks to catch up. And I see Thomas has beat us in sending the collab.
Yes,
So I will.
he did. So here you are installing some high-level package that will download all the libraries you need. So the Google Cloud AI platform for all the different Vertex AI clients, and also another one called RagStack AI. So this one is actually built and released as open source by DataStax as well. So we noticed that in the AI ecosystem, there are a lot of framework. So LangChain is one of them. Semantic kernel is another. Llama index is yet another. Longsmith. So a lot of different specialized framework, and they are not well all work together. So what we say, let's provide something called RagStack that will kind of stick the version that we have tested and work along together, and on top of that, add maybe our new model, maybe our new features. So we're working the different algorithm.
Gil, you don't have to download this. It's on Google Colab, so it's fully hosted here. You don't have to install anything, so you could work directly in the Colab. If you
Yes.
want to do it local with Jupyter Notebook, you can. And then Pranav, if just to follow up with your question, for folks who are still looking for their API endpoint, just navigate to your database on Astra, and then it should be on the right side under database details. Just copy the endpoint here, and then you also need your token.
And if you have never used a Colab, it's really working like Jupyter Notebook. Like any notebook, you have a succession of cells. Some cells are just documentation, and some cells are code that you can execute. And so to execute the code, each time you have a button on the left side, which look like a circle with like a YouTube play button.
Exactly. And you should, if this is successful, it will give you a green check next to it. So
Yes, and while it's running, it's it's super obvious. Also, take your time. Forgot to execute one cell is the most common issue you'll get with a collab, because in one cell you will define some variables that will be reused in the next cell. So if you forgot one, the second cannot use that. Yeah, restart session. It's not that a big deal. I think Melissa,
yeah.
you can skip or refresh. Both are working.
Yes. So if you restart your session, it will bring you back to, it'll just bring you back here, and then you don't have to do anything after that.
Okay.
Francisco, you can do either one.
Yeah, you can ask the question. If we don't answer live, after that maybe you put that in Q&A and we go after. But we are monitoring the question, so if we can answer quickly, we can do. So like the instruction for Astra, instead of going back, what I will do is I will show you the GitHub repo where there is again the step-by-step instruction. Let me go to the proper. Here we go. Okay, so Francisco, you put a question in here.
Okay. Manoj, yes, you do use your own API endpoint and token from the database that you've created in Astra DB.
Yes, so okay, so here, I think I can put your question here. So Francisco's asked, instead of using all the user input, which could be a very long sentence, and create, the vector based on that question, is there any technique to filter the actual question for the user input? Well, your question should match to one and only one vector, because when you do the similarity, you are comparing your question with the rest of the world. But yeah, multiple meaning, I'm not sure. The LLM has a super long context window, and it will then pick the meaning of your question. I think it's doing that under the hood, right? When you provide a sentence, it's already picking the meaning and making it a vector. Yeah, otherwise it's pre-work you have to do, as you stated. Yeah, pre-work. Also, if you have very long prompts, people tend to say that the main information is lost in the middle. So you see the accuracy of what you are doing decreasing. Yeah, so this is what I noticed. Yeah, super good question. Yes. I've also heard about semantic embeddings not so long ago. I think 3 weeks ago, we had a video to say this technique, which is semantic embeddings, to actually get you the embeddings the closest to your question and use that to look for your RAG context.
Okay, I'll move along a little quickly here. On these next few, it's okay, yeah.
Yeah, so how many cells did you execute? Okay, you got the installation, right?
Yeah, the dependencies was the one that took the longest time, so I wanted to take a moment to allow everyone to do that. And then if we're all okay, I will move on. And Cedric,
yeah,
are there
question.
Some questions remaining?
Get the code. Yeah, get the code. I think you can save. I mean, you can totally save the file. The collab is just a Python notebook file, so you just save as, and it will be something you can open in Jupyter Notebook.
Yeah, and you're right. It's also in the GitHub repo. So if you wanted to just clone the repo and then grab the notebook file from there, feel free to do so. Follow along either way.
Yes. Also, and I think we will have to keep posting the GitHub repo URL time to time, because people that missed the beginning are joining, and this is also why we wrote this very long README, is for people to be able to catch up.
Okay, I'm gonna move forward, or a few more questions.
I think you could. Looking at the time, also we still want to have time to show a bit more code instead of just imports. So here you're importing the Panda.
Yes, Laura, I'll go ahead and continue here. So yeah, we're importing some packages that we will need later on. And then we have the load credentials section here. So here is where you input the credentials that we saved earlier. So I will get my project ID.
Yes. So yeah, that's common pattern to do. When you need some inputs in a Google Colab or a notebook, you proceed like that, using the instruction get pass or input to ask live the user.
Yes.
When you execute some code like Python code, those variables will be on a file called .env and will be loaded as environment variables, because you don't want the code to know about them. And the same code will run in development, integration, production. And this is the architect that will just provide the file with the proper keys for security reasons.
That's right. Yeah. Usually in practice, we use an environment file. So this is just for the purpose of the collab. But yeah, hard coding the credentials is probably not your best bet here. Yes, Brian, great function. And Felicia, the project ID should be the first one that it's asking here in the collab.
Yeah, when you execute the cell load below Astra DB, it will ask you. Yeah, so when Melissa will not really rerun the cell, because otherwise she need to do the 3 again.
Okay. I will move on. In this next cell, it's just configuring the connection between the Colab and Google Vertex AI. So I guess this is where the local Python notebook might have some differences, because you have to configure Vertex AI. So actually in the Colab, it's a lot easier. When you run this cell, it brings up a Google authentication window, and then you can do it directly into Colab. So just a call out there. Once you got that window, it should give you the check, and then you're good to move on. Mohammed, the project ID is in Vertex AI in your project info on the top left. So you have a project name and then a project ID. The ID is what you need. Okay. So this is the fun part. We are going to import the clothing dataset. So I have this dataset here. It's a Zara public dataset living in this hugging face. You can actually visualize what the dataset looks like. We have the product name. We have the link to the product itself. We have the images, et cetera, et cetera. And the embeddings are already created for the purpose of time. But this is exactly what Cedric was mentioning earlier in his explanation of Astra and RAG. So when we do our search, we are going to reference both the embeddings, but also we might have some metadata that we can use to help filter our response as well. So that might be the category or the gender of the item, or if you have like color, season, those are some additional filters that you could add to an existing data set. But again, the embeddings are already created and they're in this living in the dataset already. So in these next 3 cells, we are just importing the dataset. And then we are storing this dataset into a data frame, pandas data frame. And then this next cell will just allow us to see the dataset here in the collab. So you should see it looks exactly like the hugging face dataset.
Yeah, so we got a great question. We say, how do we compute those embeddings? Because here it's true, in the data set, we already have the vector to get some time, but it's important to know. So when you go to the model garden, to Vertex AI, or any other LLM, I told you they are single purpose model. The model to do check completion, the model to do image generation, the model to do text to speech. It happened that there is a model or multiple model called text embeddings. And this is exactly what they do. You give them a string and they give you back a vector. And how do they do that? It's what we call a transformer function. And there are multiple algorithms. So it started with BERT, back in the day in 2008, actually invented by Google. We are yes, we are so nice with Google tonight for some reason. But it's algorithm to compute that. You don't have to do by yourself. But there are also very good model that you can run on your machine, and it's perfectly fine. By the way, if you ask how can I use those some open source model and model without paying anything or running anything, so Vertex AI, you got the free trial, but Hugging Face, here we use Hugging Face to load our data sets, I think everybody does that. But Hugging Face also have an inference API that you can call to do text embedding, to do text completion, to do image generation. They even have a stable diffusion that you can use for free here, actually. Or you can use tools like Llama, where you have like a Docker container on your machine, and you say, Llama run, I don't know, Gemini 7. It will download the model almost like a Docker image and run it locally, as long as your machine is big enough. So here we show you all the cloud services for convenience, but you can also do that locally if you want. Not today in those 90 minutes, but it's still doable.
Okay.
Okay,
Good. So just as Cedric was explaining, how do we create the embeddings? So like he said, that it's already stored in our data set, but this is just showing you briefly how it's being done. So we are calling our we're initializing our Vertex AI instance, and then we are taking this multimodal embedding model, and that's being stored into a variable model. And then what I would do is then iterate through my data frame, and then you can pass through into this create embeddings function here that you want to send the image and some contextual text. So this is where the multimodal piece comes in, because we are using both an image and some text to generate the embedding. So the vector embedding includes context from both the image and then the text that we sent. In this case, we did the product name, but you can do product description. You can send in additional things here. And what do those embeddings end up looking like? Just like this, a large string of numbers that will be used to do the searching later on.
Yeah, so Ibrahim was asking, can he do his own embeddings? And the answer is yes, you can actually invoke sentence transformer Python package. I told you in the beginning, I'm also a Java guy. So here I provide a link how to do it in Java. This is what I'm doing the most. But yeah, look at sentence transformer model as a Python package. And you can do it as well.
Mm-hmm. Yeah. We're a Google shop today, but you can store any type of embeddings. Use any embeddings model and store those into Astra DB.
Okay, so Manoj is asking about DB token and DB URL. So maybe you can show if you have it here, because it's there. It's there. Oh, okay. it was.
Yeah. If you're in the workshop, if you were in the overview, then just click your database, and then it's here on the right side under database details, Manoj. Okay, so here, very good question from Siwa. Very good question from Siwa. So how to choose the size of the embedding vector? Because if you look OpenAI, they have 1536. If they do have most of Gemini is 784. So how would you do it? Well, I told you in a vector, you can encode a certain amount of meaning. So if you can encode the meaning with the shorter possible vector, then all your system will be faster. Because if you compare two vectors of dimension n or two versions on dimension 2n, the complexity is increasing dramatically. It's exponential time of compute. No, not exponential. I think it's not as bad, but the shorter the vector, the better. So, but for here the multimodal, you need to encode both text and images, and for those, most of the time, you'll get some dimension of 1500 or even 3000 length vector. Actually, it's not you to choose most of the time. Most of the time, it's not you to choose. You choose a model,
and the model tells you which dimension is working. Why I tell you most of the time? Because 3 weeks ago, 1 month ago, maximum, OpenAI, where they introduced the new model called small 3 or big 3, it's like you have a very long vector, like 1536, and you can actually ask the model to encode as much as possible on the first 785. And when you do the embedding similarity, you can only search on the first part of the vector or the whole part of the vector to get more meaning in your vector. So that's mostly speed and how much meaning you can have and the type of data you use. Yes, we are RAG image too. If you look at what question Melissa asked, she was asking a question about the image because she uploaded the image in FashionBuddy.
Yep, good question, Francisco. No problem, Siwar. Okay,
it's
so
written like that, raging.
Are we raging images too? No, we're not raging. Okay, so what have we done up until this point, everyone? We have created a data frame within Colab that we took from the data set, and I just demonstrated how the embeddings are created, although the data set already has the embeddings. So let's move on to now loading that data frame into Astra DB. So we need to first create a connection with our vector database, and that's where our environment variables with the credentials, with the token and the endpoint, that's where they come in. So we are connecting to our vector database, and then we are also creating a collection. So in Astra DB, we have this hierarchy of database, namespace, database which has many namespaces, and then namespaces which holds collections. So in this case, we are creating a collection. I will run this cell here. And you might see that I already set the dimension, and this is just based on kind of going off of Cedric's question here with what the LLM, what the embeddings model calls for. Okay. I'm anticipating there might be some questions on the connection piece. So whoever's following along, let me know if we are okay to move on here. Just give a couple seconds. And yeah, so the namespace is also default namespace. You can configure the namespace later, but it just defaults to the default namespace that is created with your database.
Yeah.
Okay, Pranav's getting some error.
Yeah, don't be afraid that the key space is just a way to file your things. 401. 401. It's probably that the token is. Yeah, I'm not sure about your token. Maybe Astra DB token, you miss one character at the end because 401 is really meaning you don't access the API, which it seems like it's a proper URL to me.
Yeah, the URL looks fine. Sometimes the clipboard doesn't copy on the first time when you click it.
Oh.
So I usually do 2 clicks just for good measure. You might have to re-enter your credentials, Pranav. Okay, so our vector database, we've connected to it and we've created a collection as you see in our data explorer. But now we have 0 records. So we have to load some records into this collection. So what is happening here? I will run this while I speak. We are having a function called load to Astra. These first few lines are just creating some visual bar on the bottom to view the progress of each record. Here, I am going into each column from the data frame and then also establishing that as a column in Astra and saying, okay, product name, store it under product name. price details stored under the respective column names in Astra as well. And then I need to call to my API the insert one statement and insert those the records as I go through the data frame. So I'm using this collection.insert1 statement to add those to our Astra vector database. And then the exception below, it's just catching if this has already entered this record, just skip it, and then you don't have any, so you won't have any duplicates in your database. And then we call the function so that it can load it. And we pass through our data frame and then our collection that we created just a second ago. If all goes well, all of the records should have loaded, so 936 out of 936, so that if I click back into our Astra database, I should now be able to view 936 records in the collection that we created. This is some, yeah. And if you see below, we see our collection data. You could see it in this table format. So I see my vector, I see my columns, and so on, just the same way we were seeing it in the collab. But I can also see it in JSON format. And I can also do, if you click search on the right, you can also perform some vector searches just like this on the fly. And what's cool is that we also see the similarity scores. So of course, this striped shirt, if I do a search, it's going to return 100% similarity score. And as you go down, you will see other scores that are 90%, and these should be similar to the one right above.
Yes, Mohammed, a collection is an equivalent of table, but you imagine that the entries you put in a collection are JSON with multiple levels, where a table, it's all flat. So a collection is exactly what you find in a MongoDB or document-oriented DB. Question from Manoj about your error. So this error message is related, so it's a Google error message that's stating that when he tried to access the model, he was not able to have the key to use it. Oh, yeah, we did not explain how to extract a JSON, or you show how to extract a JSON from the service account?
From the Vertex AI?
Yeah, for the Vertex AI.
You didn't need to do that. If you're doing it locally. Oh, so if you're doing it locally, Gil,
Cloud
yeah.
login.
Yeah, you need to configure the Vertex AI API if you're doing it locally. Stuck in pip install. Yeah.
Yes, you can actually copy paste as is the item from it's Python. Be careful not using a too recent version of Python like 3.12, because not all the AI libraries are catching up. I think it's, as long as you not go above 3.10, 3.11, yeah. It's okay, right?
Okay, I will move on here into the meat of the app. So we connected to our Astra database now, and now we've loaded our data set into Astra. Great. So how do I now perform the actions that we will be doing when we submit some queries into this app, right? I want to be able to upload a photo, and then from that photo, it should generate some responses back to me. What's happening in the background? It's asking Astra, what similar items do we have to this photo that was uploaded by the user? And where are the most similar responses that we can return back to them as a response? So some helper functions here, just a get image. This is just returning the image that is being uploaded by the user. Now we have this get image embeddings function. So what is this saying? It's saying that the user is uploading an image. Let me turn this image into an embedding. So now I have this, now I'm speaking the same language as what is stored in my vector database, right? The user sends me an image, I translate it, quote unquote, into a vector, And then now I can perform a vector search back to Astra to return the most similar items. So that's what's being done here. Show recommendations, it just displays that to the screen for us in the collab. And then find similar items is performing what I just described, right? So we have the reference image. We might have some categories. So if we want to do some metadata filtering, we can select what categories that we want to use. And then we do a vector find to our collection. So we give it a few parameters here. We give it the embeddings. Limit 3 is just saying, give me the top three similar items. And then we could pass a metadata filter, which in this case is category. And then include similarity just means to display the score. Are we good? And then I also want to just briefly call out is the prompt that we are sending as well. It's the prompt again is you're just telling the LLM what persona to take on as they are responding to the question, right? So I told it you are finding the pieces of apparel that are similar to the item in this photo, and we only care about the apparel that the person is wearing, not anything else in the picture. Good. So time for some examples before we wrap up. So we will first run this example 1. So I can choose any file that I want to upload, but for this purpose, I will do this example. Okay. And you can take any file that you've uploaded, and on the left side of your collab, there is a file explorer that is in the collab. That's where your uploaded image is living now. And then you can copy this path and then put this path into the reference image cell here. And then when you run it, it should display that image as well as the items that we see, the similar items that was retrieved from the database. So if you remember from the beginning, if you were here, I demonstrated what this looked like in the UI. So same exact image and same exact results, but we're just seeing it here, how it's actually being done behind the scenes, right? So we've given it, again, the image, the embeddings are generated, we perform a vector search, and these are the top 3 responses that were taken from our Astra vector database. But let's connect the dots a little bit more here. Let's see what the embeddings actually look like. So if I need to update this path. So if I call my get image embeddings, it should give me the vector that was actually generated from the uploaded image. I can copy this and then go back into my Astra database, and let's use this hybrid search feature that we have in our database, Data Explorer. And I can put in the vector that I just generated from my uploaded response and click apply. And lo and behold, we see the same products that we got as a response here. So you might see the mules, the bag, the mules, the bag, and the crossbody bag. And then same thing here, we see mules, the bag, the crossbody bag as well. So cool that we were able to see what is the database seeing after we upload the photo, right? It's only seeing this vector, right? We are generating the embedding, and then we are talking to Astra and telling it here what it needs to look for. And then it's just simply returning us the responses. But to us, it's giving us some recommendations based on the outfit that we are giving it. And below, here are some more examples where you can use even just the URL. So different image, same idea, but this time I'm passing in categories as metadata. right? So now I can tell it I only want to see some responses within the categories tops, bottoms, and outerwear. And if I scroll below, it should give us category tops and then some items within tops, some items within bottoms, and in the outerwear as well. I know we had to move a little bit quickly. If there are any other questions in regards to the collab,
No,
let me know. Yeah.
For now, we caught up.
Great. That was the collab, everyone. If you have any more questions, you can always follow up with us there. But
Yes.
I think we will head back into. But basically, this was Fashion Buddy. Did it seem as hard as we thought from the beginning to create something like that? How did you upload the image?
Yeah, how did you upload the image?
So if you go here, Srini, to the example piece, it is actually asking for an uploaded image in this cell from Google Colab files uploaded, files upload. Thank you, Laura. Thank you, Pranav. I'll go ahead and stop sharing now.
Okay, so let me start sharing and move. So we are still 15 minutes. So I will go a little bit on slide as we do, a little bit of code, but I would like to save 5 minutes to play the little game, right? I want somebody here to win a t-shirt, so I have one word. So we did a collab, and so the app we built are using some orchestration framework, the framework that's doing the glue with everything we discuss, connecting to the LLM, connecting to the database. So the database in the case of vector is also called a store of a vector store. And also all different features that you would need in a chatbot, like handling the chat, handling the memory. And for that, so LangChain, Llama Index, semantic kernel are definitely the more famous in Python. If you are using Java, LangChain for J, Spring AI, and if you are using Node.js, TypeScript, LangChain JS, Llama Index JS. Je crois que now they also have it. So I also introduce you to Rackstack AI. This is what we import at the very beginning. We try to stick together the framework that work the best. And like we tried that, you import a single library and it gets you everything you need. So with this use case, we can build a recommender, because the recommender is find me what is the closest to me. Here I put a little a sphere, because you can see that your product catalog on the graph, and a vector store, a vector database. When you save your vector, it's a vector space. So each vector is a point, and you keep trying to see what are the closest to you. It's not in dimension 3, but you got the idea. So yeah, so to get a recommendation, you can do as a similarity search plus meta filtering. It is getting more and more. Okay, so after that, what we have as homework for you or going over, so we swap the Google Colab with Streamlit. So if I go to the GitHub repo, so here we did lab 1, lab 2, and if I go to lab 3, so again, we do not want you to install anything. So they ask you first to create an account in that system called Streamlit. So, it's free, just need a Google account, a GitHub account, I think. And there, actually using the repo itself and open code space. So, to do that, you go here, code space, and you click on the little plus, and it will open a full-fledged IDE on internet for you to actually work and implement a real app. So if you look at the repo, the main file you need to look is this file called fashionbuddy.py, which contains the full FashionBuddy application. If you look at the first rows, here you will see that it's all about importing the credentials, this time not by providing them, but because they are in a file called secret.toml. So here you substitute the value, and it's loaded. Then this line is ready, connect to the database, create a collection. That's just a constant. And here a few functions, which are the function from the collab. So you have your data, you have the function from the collab, you load the credentials, how to build the app. This is where Streamlit come into play. So it's a framework really oriented to do user interface for chatbot and AI. And they come with this prefix st. And if you do st.title, st.write, it will directly show you stuff in the user interface. To load an image in the user interface, you just do st image. It's almost doing HTML, right? It's a list of tags where you decide what you want to do. And the sidebar is the same. The upload file, the block to upload file is the same. So it's almost like advanced form. And what you have to do is wire the control. So when you upload a document from this UI, invoke the function that we define in the collab. And it's not more complicated than that. And if you want to do it step by step, you will see that we explain the command to so it's creating the account. It's really go to the okay, I will get to the I will get here. Okay, it's okay. Okay, let's keep moving. All right. So you go to the Streamlit folder. You create a file called secret.json, which is coming from the secret account for Google. You create this environment variable, you substitute the value, and you can just do Streamlit run the app, and you will have it running in the IDE. Don't have to install anything. It's another way to represent what we did, not with the collab, but with Streamlit. Okay. Yeah, I was fast on this part, but it would have been a bit disappointed not to show a bit more code and go to this Streamlit part. Okay.
Yeah.
All right. And I think as you did the demo in the beginning, I think we can move here and use the remaining time for us to have a little fun, if you all agree. So to play the game, actually, it's super simple. You go with your phone, open a browser and enter the go to menti.com, enter the code, or you scan the QR code. Just that.
Can I enter too, Cedric?
Say it again.
Can I enter too?
But you will win. So the idea is that you will see a few questions on the screen, okay? And if you answer fast and answer correctly, you get the most points. And we will see on the screen who answer faster. And when we're done in 5 minutes, very quick, you send me an email with your coordinates and I ship you a copy of that t-shirt, right? It's always good to end our little hands-on with a little fun like that. So I see on my screen that we are already 21. So yeah, keep going. You have one chance in 21 to go. I will keep the instruction 1 more minute and I will start just to be on time, okay?
Yes, Praveen. He hasn't started the...
No. I've not started the thing. Also, the question will show first on your phone, So if you're watching from one of the panel, which is linked in YouTube, maybe you have 2-second delay. So make sure to check your phone because your phone will be the most the most up to date. Okay,
Yes.
I think broadcast is like the direct, and YouTube has 1 second. Okay, so the first question is not even a question from the quiz. Is really where are you from? I mean, we dial at this time. So, and we want to see where are people from. Oh, wow. So we see people from Southeast Asia. Wow, congratulations.
Wow.
I'm actually at Singapore right now and it's 2 a.m.
Yeah.
So thank you for staying with us so late.
Cedric, you're not alone. You're not alone.
Look at that. And see, so it's a distributed framework. Yeah, I'm so happy to see that we have contact all over the place. And look at that. We have spent 90 minutes all together and we are almost still 50 online at the end. So pretty happy that we do that way. Okay, so now let's do the quiz. I want to end on time. Okay. So question 1 and 4. Oh, 63
Wow.
players. That's craziness. Okay, so answer fast to get more points. First, you get the question, and then you get 4 answers and pick one of those. Okay, so good luck.
Let's see these questions.
What is the name of the database we use today? Is it Astra DB, Pinecone, WeWait, or Victor? It's supposed to reward everyone that attend. Okay, this one was too easy. Sorry. So let's see the leaderboard, and this is how you see who was the fastest. So look at that. Oh, Joe. It's pretty tough. Look at that. But this time, by 2 milliseconds, it was Joe Pragash. Maybe your real name. So yeah, thank you. Okay. Question number 2. Are you ready? Let's go. What framework can be used to orchestrate a generative application? LangFlame, LangFlow, LangChain, LangUlrJS.
You have some tricked answers in here, Cedric.
Is there any? Hey, yes. So I told you about LangChain, that's right. But there is another way to orchestrate, which is visual, using LangFlow, also owned by DataStax. So maybe for the next workshop, you won't even have Python code, but it was just dragging some arrows in between blocks to do a RAG application. Okay, so this time, let's see the leaderboard. I think left side was faster. Is it enough? Oh, yeah, it was enough. Left side took the lead. Okay, question number 3. Everybody ready? Oh, we have even more player now. 67. There we go. Ready to go. How do we describe an AI model that accepts heterogeneous input type? Multilingual, multimodal, multi-type, or an octopus?
I think this one's a hard one.
No.
I think it's octopus.
So, right? Nobody is okay. This time, okay. Next workshop, I will make my question way more complicated, folks. But I'm not here to trick you. I need to, to have fun. Okay.
Left side again.
Look at Chloe. Yeah, not only is, wow, okay. It's so close. All right. Last question. Yeah, I wanted to take short. Okay. Good luck, everyone. Answer fast to get more points. What is the name of the Python framework I described at the end to build real application with web interface? Streamlit, Streamy, Django, Delete.
Actually, we didn't have enough time for some more jokes from you today, Cedric.
Right? See, eh, I'm taking some. Yeah. So Django was a kind of a trap because, yeah, we explained Streamlit, and if you join late, yeah, that's a reward. Okay, so that's the final leaderboard. So let's see who got his or her T-shirt. And okay, Love Site cannot be beaten today, so it took the lead second question, and it's our winner. So congratulations. So how to reach out to me? Okay, so I will. Yeah, to reach out to me. Yeah, my email is. Yeah, how do I reach out to me?
Left side, if you're here, can you just share your email?
Share an email to Melissa and us, and we will contact back to you. Okay. And take a picture, like showing you won. I thought I put my email there, which is cedric.linven@datastax.com, but we never know. So with that, as I told you,
Michelle sent your email website. So if you could send an email to Michelle.
Nice.
So
Thank you, Michelle. You saved me. Okay, so everything is on GitHub. You saw that. If you enjoy the content and you want to see more sessions like that, consider to subscribe to the YouTube channel at least. And also we have a Discord where we can answer questions to you after the workshop. Okay, or if you are watching a recording, you can reach out to us on this Discord, and we will be there to answer our question. And with that, I think we are just on time. So it's just the time to thank you all. And maybe, Melissa, you have a last word?
Yeah, again, thank you everyone for tuning in. I hope you enjoyed following along with us. If there are any questions regarding the collab or the Streamlit site as well, feel free to email myself or Cedric, and I'll be happy to answer your questions. We're always looking to improve on our workshops as well. So please provide any feedback. Thank you again, and thank you, Cedric, for joining so late in the hours of Singapore over there.
All right, no, my pleasure. Talk to you soon. Have a nice one.